Uh, this is my explanation for my greedy technique program for CST-201 at GCU. Start off here is my main program. You see right here, we can see the weights and the values for this bounded knapsack problem. And that's why we have also the quantity of how much items we have. Unfortunately, we do not have unlimited use of each item. So we see that in this program, I was assigned to use two techniques, the greedy technique and dynamic programming. For both of these techniques, each have the same result of the maximum weight of 650, and these are the quantities that we use to get there. You see the weights here, the values here, and I have something called true value, which I actually use in the greedy technique to show the value divided by the weight to see how much value you're getting per weight ish. And I'll explain why I use that a little later in that greedy technique. And then we also counted the steps to compare the two and how much steps they use and their efficiency. If I quick print that for us, we can see that the greedy techniques uses 183 steps compared to the 15,000, that the dynamic does. So we can see that greedy technique is far more efficient. So let's go look through why that is and how that works. So the greedy technique works by defining the problems, defining at first what the most optional choice is, and then just picking the optional choice unless you run out of space or if that choice is valid. So we do this by using a double array. We define the true value of each of those. True value is really simple. It's right here. It's just right here, actually. It's just the value divided by the weight. Pretty simple. We have an array of that to store. Then I use recursion to continuously choose the best option, add that to another array that determines how much of each item we use. Just using a best index method that I have right here. And how I defined the best index was they have a value divided by weight of at least 2.0. For this one, that's my cutoff. And then got to make sure that it's valid. It's not, we have enough space left in the total weight for it. And it's not infringing that we can't have any more space left if we're cutting off at the wrong point so that we can't get any more items in. And then we just choose the best item from there. So that way we can save a lot of time. Now, dynamic works a little different. You have to find the best choice every time and define what the best choice is every single time you're choosing a choice. That's why it is significantly slower and less effective while still getting the correct result to solve this problem. So that is my quick little explanation of how the greedy technique works and why it is so much better and more efficient than some dynamic programming, at least for certain problems where the greedy technique really benefits. And that is the solution to the knapsack problem. And I hope you enjoyed this video and how I did it.